Hey guys, welcome back. Today in day 2 of right triangle trig, we're going to continue with the same 6 trig functions and just keep working through a lot of similar problems to what we were doing in the other video. So just as a recap, these are the 6 trig functions that I'm talking about, and we learned that they are just reciprocals of sine, cosine, and tangent. So cosecant is just the reciprocal of sine. Notice that what's written here, opposite over hypotenuse, and then it turns into hypotenuse over opposite. They're just flip-flopped. And the same things are true of the other ones. Secant is just the reciprocal of cosine, and cotangent is just the reciprocal of tangent. Remember that an easy way to remember which one is reciprocals of which is write out sine, cosine, and tangent in the regular way that we would normally see it in SOHCAHTOA. So in SOHCAHTOA, it goes in that order, sine, cosine, tangent. So write those words out in the same way. And then if you can just remember CSC at the top, and then go down with the exact same abbreviation, C, which we already have, SC, and then fill in the blank, secant, cotangent. And then that helps you remember which one is reciprocals of which. So sine and cosecant are reciprocals, cosine and secant, and tangent and cotangent. Alright, so let's move on to doing a problem. So these problems look a little bit different because we don't have a picture with labeled signs. What we do have is something like this. We know that the sine of theta, some angle, some acute angle in our triangle, is 4/7. Well, remember, let me write out SOHCAHTOA, that sine is opposite over hypotenuse. So what this is telling me is that from the angle, the opposite side is 4, and the hypotenuse is 7, just coming straight from our definition of sine up here. Okay, so let's go ahead and draw a picture of what this is representing. So we first know that we have a right triangle, so I'm going to draw it something like this with a 90-degree angle. Theta is one of the acute angles, so it doesn't matter if we put it up here or if we put it down here, just pick one. I'm going to choose to do the top one just since that's the one that I did first. And from that angle, that is a terrible right triangle, let me clean that up a little. From that angle, we know that sine is 4/7. So the opposite side must be 4, and the hypotenuse must be 7. So although it didn't give us a picture, because it did give us the information about sine, we can use that to create our picture. And then the only other thing I need to do to get the third unknown side is do the Pythagorean theorem to find what that last missing leg would be. So since that's a leg, not a hypotenuse, let's call that B. And I can set up the Pythagorean theorem. 4 squared plus B squared equals 7 squared. 4 squared is 16, and 7 squared is 49. When I subtract both sides by 16, I get 33. So that's not going to be a perfect square root, but I'm going to take the square root of both sides, so b is equal to the square root of 33. And now I will put that in simplified radical form. I'm going to clear my screen and do that. So I'm going to erase everything in here and just put this part at the top and write that in simplified radical form. So if you need to pause the screen and look at that work, go ahead and do that now. Alright, so let's break down the number 33. The first thing I think of is 3 times 11. And actually, both of those are prime numbers, so it can't be broken down any further. So square root of 33 is already in simplified radical form, and I'm going to come back over here to my triangle and write that in. That my third missing side, my other leg, is square root of 33. Alright, so now it'll be pretty easy to write the 3 trig functions, sine, cosine, tangent, and then their 3 reciprocals. So let me just start off by filling it in sine, cosine, tangent. We already know that sine is 4/7. That was given to us in the problem. And let's do cosine now. So again, from the perspective of this angle, cosine is adjacent over hypotenuse. The adjacent side is this one right here, square root 33, as it's touching the angle, and the hypotenuse is 7. Since the square root is in the numerator, we don't have to simplify anything anymore. We are good to go. And for tangent, tangent is opposite over adjacent, so that would be 4 over square root of 33, since 4 is the opposite side and square root 33 is the adjacent side. Now that is an issue because now we have a square root in the denominator, so I'm going to rationalize by multiplying both the top and the bottom by square root 33. What that does is in the bottom, this we just get regular 33, and in the top we get 4 square root 33. The only thing you need to look for after you're done rationalizing is just see if this fraction can be reduced. But the only thing that 4 can divide by is 4 and 2, and 33 doesn't divide by 4 and 2. So then I know that this is my final answer. I'm going to erase the work that I have and just write that as my final answer. Alright, so now let's work on the reciprocal functions. Remember, I can start by writing CSC and then going down with those same letters, CSC, and fill those in. And they're just the reciprocals of the ones that they are next to, and if there ends up being a square root in the denominator, I just have to rationalize that out. So let's start with cosecant. That is the reciprocal of sine, so all I need to do is flip this fraction, so it would be 7 over 4. And let's do the next one. Let's do secant, which is the reciprocal of cosine. All I need to do is flip the fraction, so it would be 7 over square root 33. Now that's an issue because we do have a square root in the denominator, so I'm going to multiply both top and bottom by square root 33. And in the bottom, this part right here would just become 33. So I'll erase that and just write the number 33. And then we always want to check and just see if this number can, or this fraction can be simplified. It cannot because 7 is a prime number. So my final answer is 7 times square root 33 all over 33. I'm going to write that a little neater right now. Alright, and lastly we have to do cotangent, which is just flipping the fraction of tangent. So I'm going to take this fraction over here and just flip it. So 33 over 4 square root 33. And the only issue with this is that we do have that square root in the denominator, so I'm going to multiply both the top and bottom by square root 33. And this part of it right here will turn into 33, but we do still have to multiply it by 4. So 4 times 33 is 132. So I'm going to erase this and write 132. And then the only other thing we need to do is just double check that this part of the fraction doesn't reduce. So I think of factors of 33 being 3 and 11, and 132 does divide by 3, and you get 44. So let's divide both those by 3, and you would get 33 divided by 3 is 11, and 132 divided by 3 is 44. And after doing that, it might stand out a little more obvious now that we can actually take this further. 11 divided by 44, you can divide both of those numbers by 11, and you would just get 1 over 4. And so let me now clear this whole area and write that as one simplified fraction. Alright, so my final answer would look like this. Note that it's not necessary to put this 1 here. We could always take that off because timesing by 1 doesn't really do anything. And this is still the exact same answer, root 3 over 44. Okay, so this is pretty much the exact same thing from the other video yesterday. The only thing different is instead of starting off with a picture that looks like this, we start off with one of the trig functions already given to us and we develop the picture. That's really the only difference. So I want you guys to try this next example on your own, and when you're ready, hit play, and I'm just going to pop it up with all of my answers already simplified into radical form with fractions reduced. So take a second and get your picture set up using this and fill in your 6 trig functions. Alright, here's step 1. Before I show you the trig functions, you first had to write the triangle using the trig identity they gave here. Since it was cosine, then I know the adjacent side was 7 and the hypotenuse is 10. And so that's how I filled it in. From this angle here, 7 is the adjacent, 10 is the hypotenuse. I did Pythagorean theorem to solve for the third missing side, the other leg, and I got that to be the square root of 51. So from here, you can write your 6 trig functions. Alright, so now would be a good moment to pause the screen and look over your 6 answers here and just make sure that you got it correctly. Once I was doing the reciprocal functions, I first flipped the fractions and wrote that in blue, and then boxed in my final answer in green once I rationalized the denominator. So check that you got all that correctly. Since 51 is a prime number, I never had to reduce any of the fractions like this part. Couldn't go any further, and so it made it pretty easy on us. Alright, and the last example I'm going to show you today, and then have you guys practice one on your own, is how you would solve when the angle is the thing that's unknown. So you're still using trig here, and you're still going to use SOHCAHTOA, but this time the angle is the missing piece. So let's figure out from this angle what sides we have. Well, straight across from it would be the opposite side. When we have that, that's 3. And right next to it here would be the adjacent side. And this one over here that we don't have is the hypotenuse. So the numbers I'm working with are 3 and 4, and they're opposite and adjacent. So what we need to think about is in SOHCAHTOA, since we have opposite and adjacent O and A, which trig function should I use? Well, tangent is the only one that uses O and A for opposite and adjacent. So what I can say is the tangent of theta, that angle, is equal to 3 over 4, opposite over adjacent. And now I just have to figure out a way to get theta by itself. I want to solve for theta and figure out what angle that would have been. So I somehow need to get rid of tangent. And a lot of people would say things like, oh, I'm going to divide by tangent or something like that. And that would be false. Tangent is an entire function. It's not a number right now, and so you can't just divide by an entire function. But what you can do, and this goes back to geometry, is you can take the inverse tangent of both sides, and that will undo tangent. And so what that will look like then is theta equals the inverse tangent of 3 over 4. And then we just have to type that on our calculator. So let me remind you a few things on your calculator. So first, you want to make sure that your mode is in degrees. Otherwise, you're going to get really weird answers. So this button right here that says mode, you're going to hit that button. And then down here at this line, you'll see that it says radian and degree. And right now you can see my calculator is highlighted on radian. Just want to hit the over button and select degree and then hit enter. And once you're done putting your calculator in degree mode, you can quit out of that screen. And an easy way to quit is just hit second and then this button right there, that actually the mode button again, and you can see the words quit are right above it. So quit out of that screen when you're done. Now you are in degree mode, so you're good to go. And remember, the problem that we need to type in is this right here, inverse tangent of 3 over 4. So here's how you type that in. Sine, cosine, tangent are down here, and you'll notice right above in these blue letters right here are the inverse functions. And so what you want to do to get that is hit the button that says second and then tangent, and then you'll see that it looks like tangent to the negative first power. That's what it looks like. That's not what that means. It means inverse tangent. So you'll see that pop up on your screen, and then you can type in 3 divided by 4, and you'll get your answer for that degree value. If we're rounding to, let's say, 1 decimal place, then that would be 36.7 degrees. So I can now go back to my problem and say that theta equals 36.7 degrees. And that's my final answer. Alright, so last one is I'm going to have you guys do one on your own, again using SOHCAHTOA. And you're going to have to do some sort of an inverse trig function. And go ahead and set that up and then use your calculator to solve for theta. So pause your screen here and go ahead and do that. Alright, and here's what I got as my final answer, that theta is 61.9 degrees. I used sine because from theta I had the opposite side and I had the hypotenuse. So I knew I was going to use sine and set that up, and then to get theta by itself I just had to inverse sine both sides, which is why I wrote down the second line. And then once I typed that on my calculator in the same way that I did in the last one, I got 61.9 degrees. And that's it for today, you guys. So it's really similar to the video from yesterday. The only difference today is that instead of starting with the picture, you can start from a trig function and value like this, where it already gives you a fraction and you create the picture. So that's one part of today's video. And the second part is just making sure that you can find theta when given a triangle using inverse trig. Alright, have a great day, you guys, and I will see you later.